so for lesson 4, what I want you to do is you have room at the bottom of your page on page 465. I want you to write this word discontinuities. So just at the bottom of this page. Discontinuities. Rational functions could have two different types of discontinuities. The first type is what we just did, and they're called vertical asymptotes. Okay. Or even horizontal asymptotes. Your graph is discontinuous. There's a break in your graph at the asymptote. Okay, so that's what a discontinuity is, a break in your graph. There's actually a second type of discontinuity, and there could be holes in your graph. And we'll put it in our calculator, and you'll see there's going to be an actual hole in the graph. You need to be able to figure out when you're given a function if it's got VAs or if it's got holes. The only thing you need to remember for this is the following. VAs will have no common factors. So just write that and then I'll give you an example. So no common factors. Holes in your graph will have common factors. And if you have a highlighter, take it out because I'm going to highlight the common factors. I'm going to highlight the holes is what I do. So there's two types of discontinuities, right? VAs and holes. VAs, no common factors. Holes, common factor. Flip your page, and at the top of 466, write this function here. So f of x is equal to 2x over x plus 1. This would be an example of not having a common factor. Having an example of a common factor would be something like, it would look like this. X plus 1, x plus 1, and x minus 2. This is an example of a common factor. X plus 1 and x plus 1, they're what's called common factors. If I have a factor of x plus 1 in the numerator, or sorry, in the denominator, there's no x plus 1. No common factor. If there's no common factor, your graph is going to have a VA at, and then we did this one in the last lesson, there's going to be a VA at x is equal to -1. Now I'm going to show you an example of a common factor. Okay, so this one right here, we're always going to be factoring polynomials from here on out. So if I said, what gives a product of 2 and a sum of 3, what would be the two numbers? 2 and 1. Okay, so let's write b of x is equal to, you said 2 and 1, which is correct. So x plus 2 and x plus 1. The denominator has x plus 1. And I'm going to put that in a bracket. There's a common factor here. So students that don't know about common factors, they'd say, oh, there's going to be a VA at x is equal to -1. There won't be. So what happens here is I'm going to use my highlighter, and whenever I see a common factor, I highlight it. Okay. This graph has a common factor. Therefore, this graph is not going to have a VA at x is equal to -1. It is going to have a hole in my graph, and the equation of the hole is going to be at x is equal to -1. So it's going to be the exact same thing. You got to find the non-permissible value, right? So the non-permissible value of this graph was x plus 1 cannot be equal to 0, x cannot be equal to -1. You just have to figure out, is that guy going to be a VA or is that going to be a hole? Because there's a common factor, there's going to be a hole in this graph. So what I want to do is let's look at the graph first. When you punch this into your calculator, always punch in the original. Okay, so make sure, and I want you guys to punch this in on your graph so you could see it. Make sure the numerator is in a bracket and make sure your denominator's in a bracket. Hopefully it shows it. Sometimes the graph shows holes really well and sometimes they don't. And it's not, but I just want to see something. I'm going to change my window. I know that there's going to be a hole at -1. There's going to be a hole right here. So I'm going to change my window from -5 to 2. I just want to see if we could see it better. Because actually we can't see it at all right now. Nope. And I'm going to try one more thing. Window. I still can't see it. There is a hole. Here's how you could see the hole. Go to second function, trace a value, type in when x is -1. Does it give you a value? No, that's the hole. Okay, so there's a hole right there. The other way you could see that hole is in your table. And if you were at -1, you'd see this. That error is a hole in your graph. And I'll show you how to draw the hole. You need to figure out what the y value of the hole is. So here's how you figure out the y value. Once you've got your common factor and you figured it out, it's a hole, let's cancel those common factors. And then we're left with b of x is equal to x plus 2. That's a linear line, right? And if I look at this graph, this is the equation of x plus 2. It's going, the y-intercept here is 2. To find the hole, though, we need to plug in this -1 in for x. So we need to plug in b of -1. So wherever you see an x, put in your -1 plus 2. The whole of the graph, -1 plus 2, is at 1. So what that means, and I'll write b of -1. So there's a hole in my graph. You need to know the coordinates of the hole. It is at x is -1, because x can't be -1, and the y value on the hole is at 1. So on this grid here, where x is -1 and y is 1, you need to draw an open circle. Then you would draw, you'd use your ruler. I know that the y-intercept is going to be 2, so it's going to go there. X-intercept is -2. Mine's slightly off. But that's how you would draw it. So that should be on a straight line. And then you would draw your arrowheads, and that would be your graph. Here's how we write the domain and range of this graph. The domain, x is such that, what could x not be? What is it? -1. Always this. What was the non-permissible value? X could not be equal to -1 XER. Anybody know what the range would be? It's not going to be YER. There's one value that Y could not be. 1. Yep, it's always going to be the Y value on your hole. Y cannot be equal to 1, but other than that, YER. Let's do one more that's going to have a hole. And then tomorrow we'll do graphs that have both holes and VAs. Okay, so again, I don't want to do this one. We're going to look at a nice simple function. F of x is equal to x squared minus 25 all over x plus 5. you always factor. Make sure numerator and denominator is factored. How would you factor the numerator? It is a difference of squares. Square root of x squared is x. Square root of 25 is 5. Difference of squares, one has a positive and one has a negative. The denominator was x plus 5. We need to figure out, this is going to be my non-permissible value of negative 5. Is it a whole or is it a VA? If there's a common factor, I'm going to highlight it. What does the common factor mean? Whole or VA? It is a whole. So common factor, there's going to be a whole in this graph. Okay, how do you get where the whole is? We do the same thing we've always been doing. You take that denominator, whatever that denominator is, and it cannot equal 0. You solve for x. X cannot be equal to negative 5. That's the non-permissible value of this graph. Once you get to that point, you would then say there's a VA at x is equal to negative 5, or there's a whole at x is equal to negative 5. So there is going to be a whole at, and what I'm going to do is I'm going to put negative 5 in here, and then I always leave the y blank because I have to calculate what the y value of the whole is. How you calculate the y value of this whole is once you've done that, you then simplify your equation. And what am I going to calculate? F of what number? Do you know? Negative 5. I need to find what's the whole going to be. What's the y value when x is negative 5? So I'm going to put a negative 5 here and a negative 5 there. F of negative 5 is equal to negative 10. There's going to be a hole in my graph, and the coordinate of the hole is at negative 5, comma negative 10. How you would draw that is as follows. You just get that hole in first. So x is negative 5, and y, I'm just going to guess, down here, I'll say that's negative 10. You would plug this into your calculator, the original, right? So I'll plug the original in. So the original was x squared minus 25, just because we want to see the shape, over x plus 5. I know it's going to be a line though, right? When I graph that guy, there's the graph there. Second, calculate a value. When x is negative 5, there's no y value. That's the whole, right? Or I could look at the table. When x is negative 5, there's a hole right there. I want to know what, so this intercept here is going to be negative 5, and this guy's 5. So what I'm going to do, just to make it look like I'm doing this accurately, is you would draw with a ruler, so just use your ruler. You would draw your straight line going like that, and then you would say this is negative 5, and this is 5. And then you've got an accurate diagram, right? You've got your hole, you've got your y-intercept, x-intercept. Write what the domain of this function is. And then write down what the range of this function is. Jaden A, what could x not be? Yep. So x cannot be equal to negative 5, comma xer. Connor, what can y not be? It's at the hole. Look at the hole and the y coordinate of the hole. That's right. So y cannot be equal to -10, but other than that, y-e-r. Okay, we will finish this off tomorrow.